All right, the next section looks at a little bit of economics, and there's a lot of calculus in economics that we can use, and business calculus and business math and things like that. First, let me tell you a couple of big ideas. What we do is, when we're looking at most types of business situations, we'll typically have a price function, which is just basically based on the law of supply and demand. Essentially, the idea is that the more you charge for something, the fewer units you're going to sell. And that's a fundamental idea called the law of demand. And so you'll notice that in this function, the price function is 150 minus 0.75x. And that's because the higher p gets, the lower x gets. And so the cheaper it is, the more we'll sell. The more expensive it is, the fewer we will sell. The revenue, so that's just some function. The revenue function is how much money we make. And the revenue function is going to be whatever our price is times the number of units we sell. And that's just the revenue function. So it's our price times the number of units we sell. So if you're selling soda for $3 a can and you sell 300 cans, you just times 3 times 300 and that gives you your revenue. Cost is another function. Usually as we produce more and more, the cost of something can go down. However, it can also go up. It really just depends on the type of product it is and what the economies of scale are. So your cost will also just be some function. And the last function you need to know about is profit. And sometimes we use the symbol pi for profit to differentiate it from the price. But in any case, the profit is simply equal to your revenue minus your cost. And the goal of any business is to make the profit as large as possible by maximizing your revenues and minimizing your costs. And that way you can have new money to invest in your business or hire new people or make investments or save or donate to charity or do lots of really good things. All right, so there's your Business 101 class from Mr. Carlson. Anyway, we're going to use these 4 ideas to solve this problem right here. A clothing store determines that to sell X units of suits, the price must be this equation. Total cost of producing the suits is given by this. Now, in real life, we would use regressions and we would estimate these curves based on past data. But to simplify the problem, we'll just take these 2 equations as given. First question is, what is our total revenue? Well, we find the revenue, as I said, by simply multiplying X, which is the number of units we sell, times the price. So the revenue is just going to be X times whatever our P function is, 150 minus 0.75X. And that's really all there is to it. You just take price times the number you sell. So that's going to be 150x minus 0.75x squared. And that right there is your revenue function. What is the profit function? Well, to do that, we just take our revenue function and subtract our cost function. So 150x minus 0.75x squared, that's our revenue function. Then we subtract the cost, and you should put that in parentheses. Just like that. So this is our revenue function minus our cost function will give us the profit function. So if we simplify that a little bit, this will be negative 2,000 and this will be negative 0.75x squared. So add those up, it'll be negative 1.5x squared plus 150x minus 2,000. So this right here is your profit function. Pretty straightforward. Just do revenue minus cost, and that's it. So how many suits must the company produce and sell in order to maximize the profits? Well, because we've got our beautiful profit function, you know the drill. All we got to do is take the derivative and set it equal to 0. So the rate of change of our profit function is, derivative of that is going to be negative 3x plus 150, and the negative 2,000 goes away. You know, that negative 2,000 can often be seen of as fixed cost that won't affect how many we sell, whereas these 2 terms are variable cost, which change as we change how many we sell. Anyway, for our purposes, we just need to set the derivative equal to 0, subtract, and then just solve. Really straightforward. You get an answer of 50 suits is the number that we sell. If we sell or make any more than that, we lose money. If we sell any fewer than that, we lose money. 50 is the exact number that we should sell in order to clear the market, cover our costs, and make sure that as many people who can buy them as they want to can at the price that we're charging. That's it. Isn't that awesome? It's pretty straightforward. To find out what the actual maximum profit would be, you would just take this 50 value and plug it into the function. I'm going to spare you from doing that. If you did that, you should get $1,750. I wish it was a million. We'd make $1,750 of profit when you plug 50 into that. And so then the question is, what should we charge per suit in order to maximize that profit? Well, in order to figure out the price, you just take this 50 and plug it into the price function. So you plug into the price function 150 minus 0.75 times 50, and that tells us what price we should sell our suits at. And when we do that, we get a price of $112.50. If you wanted to, you could also figure out your cost and your revenue by taking in 50 and plugging that in for X in either the cost or the revenue functions. So obviously this is a simplified model, but the idea of the derivative can be useful in business and in figuring out what price to set things so that you can make as much profit as you can, so that you can grow the size of your business. That's all I'm going to really talk about on this section. All of the problems kind of follow this flow. If you have any questions on any of them, please let me know, and I will see you in the next section.